All right, in this example, we know that the coordinates of the endpoints of GH are G at -3,5 and H at 6, -4. And we want to determine the state of the coordinates P such that the partitioning point such that GP to PH is going to be 1 to 2. So the first thing that we want to do is draw out a line with our endpoints, and we can label this. We know that G was at -3,5 and H is at 6, -4. And then we know that we need our partitioning point on here, and we don't know the coordinates of it yet, but we know that we can label this, and we know our ratio is 1 to 2. So this would be our ratio right here. And then the next thing that we want to do, we want to determine the fraction that goes with the ratio for each part of the line. So we can add these together, and this will be the denominator of our fraction. So we get 1 plus 2 is 3. So we can rewrite this. Instead of 1, we can say that this is 1/3. And instead of 2, we have 2/3. Next, we want to multiply this fraction by these coordinates and this fraction by these coordinates, so kind of multiplying across almost. So we have 2/3 times -3, and we can think of this as a fraction, -3/1, which will give us -6/3, and we don't want to simplify our fraction yet. And then we also have 2/3 times 5, which we can think about as being 5/1, which will give us 10/3. And then doing the same thing, 1/3 times 6/1 will give us 6/3, and 1/3 times -4/1 will give us -4/3. So these represented our x coordinates, and these represented our y coordinates. And next we want to add together our x's, add together our y's. So if we do this, we get -6/3 plus 6/3, which will just give us 0. And then 10/3 plus -4/3 will give us 6/3. And now we can simplify to 2. So our x coordinate for our partitioning point will be 0, our y coordinate will be 2. So we can write P as an ordered pair, 0, 2.
All right, so we're going to look at partitioning. So the example says find the coordinates of P such that it is 3/4 of the way along the direct line segment from C, and it gives us a coordinate to D. So the first thing I'm going to do, let's just draw a line segment. Okay, so I'm going to get this little picture up here to help us keep track. We're going to say C is 6, -5, and D is -3, 4. And I know that my partitioning point P is going to be 3/4 of the way. So point P, which we don't have the coordinates of, that's what we're finding. So it's 3/4 of the way. So we know with partitioning we want to have two fractions. So if this is 3/4, what can I add to 3/4 to get 1? And that's going to be 1/4. Okay, so now I have my two fractions. I'm going to cross multiply, so this fraction is going to be multiplied by point C, and this fraction is going to be multiplied by point D. So that's going to give us an x and a y value. So x, so if I look at my x values first, I'll say 1/4 times 6. Okay. And then my y value for that same one is going to be 1/4 times -5. Okay, and next I'm going to add that to the other one, which now we're going to look at 3/4. So 3/4 times -3 for our x value. And then 3/4 times 4 for our y value. Okay, so when I multiply these, 1 times 6 is 6/4, and 3 times 9 or negative 3 times 3 is negative 9 over 4. Remember, we don't want to simplify this, because if we simplify this, in order to subtract, we need common denominators, so we'll have to go backwards again. So we're going to leave it like that. When I subtract 6 minus 4 is, 6 minus 9 is negative 3. So our x-coordinate for point P is negative 3/4. So now let's look next at our y-coordinate. So 1 times negative 5 is negative 5, and it's over 4. And then 3 times 4 is 12 over 4. And again, we're not going to reduce that because now we want to add these together. So negative 5 fourths plus 12 fourths, so negative 5 plus 12 is 7. And then it's going to be over 4. That's our y-coordinate. So now we have our partitioning point that's negative 3/4, 7/4 as our ordered pair for point P.